Okay, let's look at our Chapter 10 reviews. We've been studying our conic sections and solving systems of nonlinear equations using these conics. So looking back at the beginning, we studied our parabola. And so these first few examples deal with the conic section of the parabola. It says here, define the vertex, focus, and directrix of the following parabolas. So you can see in this equation, we've got an equation of a parabola. We have one squared term, the x term, and a first degree variable term, the y term. So with that, we're looking at a quadratic, right, a parabola graph. And with this one being an x squared graph, this is a quadratic that opens up or down. Now, being the coefficient of x squared is negative, we have a quadratic that opens down. So again, I know a quick picture, just based off this equation, it's an upside down U-shaped graph, but we're looking for that vertex, right? That ordered pair, H and K. Now what we want to remember is our standard form. So as we go back to the beginning, let's talk about the standard form of a quadratic of the form y equals x squared. And with that, the standard form is we want to create the square with x, right, and get it by itself on one side of the equation. And then on the right-hand side, we'll put our first-degree variable. And the coefficient of that variable, y, minus some number k, is the coefficient for p. And p tells us about our focus and directrix. So that's our standard form. So as we're looking at negative 1/8 x squared equal to y, right, we want to go ahead and multiply both sides. So let's go ahead and take this equation and let's go ahead and get the x squared term isolated. So I'm going to go ahead and multiply both sides by negative 8, right? So I can get rid of that coefficient of negative 1/8. So negative 1/8 times negative 8 is 1. So they cancel out. So we have x squared equal to negative 8y. Well, with x squared equal negative 8y, we now have our standard form. So as you look in this equation of the quadratic, it's in the form of x minus h squared equal to 4p times y minus k. Right? So as you're looking at this equation, you could go ahead and write it in that form, right? You could say x squared is x minus 0 squared equal to negative 8 times y minus 0. So again, there's h, right? There's 4p, right? And here's k. So with our vertex, right, as we go ahead and talk about the vertex of this parabola, let's go ahead and write in that ordered pair, h and k. And we get what? 0, 0. So its vertex is at the origin. So again, if you're going in here to graph, let's go ahead and put this parabola on the xy axis. So our vertex is 0, 0, and we know it opens down based off the negative coefficient. So there's a quick sketch of the vertex and that parabola, vertex being that max point. Now let's find the focal point. So let's talk about the focus and the directrix. So what is the focus, right, for this parabola? And the focus is that fixed point that's inside the parabola that our parabola will focus on, and that we start measuring distances from. So remember, the focus, that fixed point, and your directrix is a fixed line. If you take any point on a parabola and measure the distance to the focus and to the directrix, those distances are going to be what? The same. They're going to be equal. Remain the same throughout on that parabola. But to get the focus, we need the value of p. What does p equal? So we know that 4p is equal to negative 8. So as we go ahead and solve for p, we get p equal negative 2. So p equals negative 2. So that means we're going to go down 2 units, right, from the vertex. So our focus is going to be down here at 0, negative 2. So there's that distance of p units. So p equal negative 2. So we have a focus of 0, negative 2. Now our directrix, remember, is our equation of the line that's perpendicular to the line of symmetry, which is the y-axis here, the line that splits this parabola right down the middle into equal parts. Well, we're going to go up 2 units. So if P being negative 2, so we go up 2 units, we'll be looking at the horizontal line, y equal to 2. So there's that distance, right, of 2 units. P equals 2. So again, there's the directrix. So it's the equation of the line, y equal to 2. So again, up 2 to the directrix, down 2 to the focus. Again, measuring from our vertex. So we found, again, the information that describes this parabola, right, that we have in front of us. All right, let's move on. Let's find out what the equation of the parabola is given the following conditions. So in this next problem, number 2, they give us the focus and they give us the directrix. So I like to see a visual of it. So that's the first thing I'm going to do. Let's draw a picture of this. So let's go ahead and build in a picture of this parabola. Now our focal point is at 5, 0. So I'll go right 5 units. And I'll plot the focus. And my directrix is over here at negative 5. So let's go to negative 5 on the x-axis, and we'll draw in the directrix, which x equal negative 5 is the equation of the vertical line at negative 5 on the x-axis. And we know from definition of our parabola that the vertex is always the midpoint of these two, because remember, any point in the parabola is equal distance from focus is directrix. So again, there's that value of 5 units that we would travel from the vertex. P would equal 5. So we've gone 5 units to the right and 5 units to the left, right, to get to the focus and the directrix. So as we're drawing in the parabola, you can see this is a parabola that opens to the right. We want to sketch it in. There's the graph of my parabola. And again, the vertex here at the origin, 0, 0. So there's the vertex there in the middle. So there's H and there's K. So remember now our equation form, what's the standard form equation for a parabola that opens right and left? We're going to have our y term as our squared term. So y minus k squared equal 4p times x minus h. So that implies what? Y minus 0 squared equal 4p, and p is 5. We went 5 to the right and 5 to the left to get the focus and directrix, times x minus the x coordinate of the vertex, which is 0. So x minus 0. And there's my equation. As we simplify that, y minus 0 is y. 4 times 5 is 20. X minus 0 is just x. So I get y squared equal to 20x. All right, so let's move on to problem number 3. Find the vertex, the focus, and the directrix of the given parabola. Now, with that said, all right, we have in this problem standard form right in front of us. So we have our standard form parabola, right? We have y minus k squared equal to 4p times x minus h, right? So as you're looking at it, now it might help you. Let's go ahead and take this equation down here beneath this. If you want, we can go ahead and take x plus 2 and write as x minus negative 2. But again, here is my values that I'm needing. There's k, right, the number subtracted from y. Here's the value of 4p, and here's h, that number subtracted from x. So again, our parabola, we're looking at our information, so our vertex, so again, our starting point of the parabola, the ordered pair h and k, would be negative 2, 5, right? X term gives me x coordinate, y term gives me y coordinate. Let's subtract them x and y. And now to find our focus, right, we want to get to the focus and the directrix for this parabola. We're going to need the value of p. So remember, 4p, we know 4p is equal to negative 4. So let's go ahead and divide out the 4 on both sides. And with that, we get p equal to negative 1. So if p equals negative 1, now in a parabola like this one. So a y-squared graph, we know it opens right or left. So if p equal -1, we're going to go left 1. So what's left 1 from the vertex? So it will be the point -3, 5, right? Would be left 1. So it might help you at this point to go ahead and graph in. Let's go ahead and sketch a picture of this parabola. So vertex left 2 up 5 up here is our vertex at -2, 5. And again, since it's a y-squared graph, we know it opens to left to right, and we knew it went left because of the negative coefficient. So here's that distance I just traveled, left 1 unit. So P, again, this point, there's -3, 5. There's the focus. So there's that focal point, and there's that distance of P. So P equal -1. Now we go right 1 unit. So if you go right 1, you'll be over here at -1 on the x-axis. So I'm going to draw in the directrix. So what's right 1 of -2? That will be the line x equal to -1. Right, there's the directrix. So our directrix is the vertical line x equal -1, right 1 from the vertex. So again, equal distance to the focus as it is to the directrix. So we went left 1 and we went right 1. So distance of 1 unit. All right, so we've got a picture of it. So we've got our key pieces, vertex, focus, directrix, right, for this parabola. Right, so that's our information here we were looking for in this parabola. All right, moving on to the next one. Let's go ahead and look at the next one here. In our next problem, we want to look at another equation of parabola. And I can quickly glance and see I'm dealing with a parabola because what? I have one squared term, the x squared term. So with that said, what's our standard form? Let's write it over here to the side. So our standard form for this parabola, right, let's go ahead and draw off a line, would be x minus h squared equal to 4p times y minus k. So let's go ahead and get that. So what we're going to do is we're going to go ahead and group the x terms together on one side. So I got x squared plus 8x, and then I'm going to move the y term and the constant term to the other side of the equation. So we've got to isolate it. So let's go ahead and move those two terms over. So we're going to subtract 8y, and we're going to subtract a 24 over, right, to get rid of those. So with our equation now reads x squared plus 8x equal to -8y minus 24 as we move the terms over. All right. Now we got to create the square with x. So that's going to be our next step. So we got to create the square with x. We got to make sure the coefficient here is 1, which it is. Right. So now what we want to do is we want to take the half value of b. So remember b is equal to 8. We're going to take half of that to create a square. So if we take half of that, we get 4. So again, we're completing the square here. We'll make a note. Complete the square. So as we do that, we're going to add in that new constant. So we want to add in half of b squared on both sides of this equation. All right, so let's go ahead and do that. So let's add it in. I'll put it in a different color. We'll put it in blue. So let's add in half of b squared. Now whatever we do on one side, we must do the other. So we add in half of b squared to both sides of the equation. Now what that allows me to do is now take this new quadratic trinomial, x squared plus 8x plus 16, right, and write in my square. So this is the same exact thing as saying x plus half of b. X plus 4, right, half of 8 is 4. Yeah, if you square x plus 4, you're going to get x squared plus 8x plus 16 back. X squared plus 8x plus 4 squared. Right, x plus 4 times x plus 4. So again, I've rewritten it as a square, so now I can already see what the x coordinate of vertex is going to be. right? I've got the square for x. It's going to be x minus -4, so -4 will be the x-coordinate. Now let's go ahead and simplify on the right-hand side. We got -24, right, plus 16. So I've got x plus 4. I'm going to go ahead and rewrite that with a minus sign. X minus -4 squared equal to -8y. -24 plus 16. That's a -8. Now I'm not quite there. What I want to do on that right-hand side, right, is we want to go ahead and factor out. So remember, we want a coefficient, right, a y right here to be 1. So we need to factor that 8 out. So as we do that, we factor the -8 out, we'll get that coefficient of 1 with y. Now you got to factor out the -8 from both of these terms. That's going to be a -8 times y plus 1, right? As you distribute that back through, you get -8y minus 8. Well, now we're there. We're right where we want to be. We've got our standard form equation. So you can see in this equation, right, you can look at it now and see the values of h, right, the value of 4p. 4p is -8. And of course, the y coordinate of the vertex, what's subtracted from y, I'm going to rewrite it with minus, is a -1. So again, there's those values. Go ahead and make note of them. So there's h, there's 4p, and there's k. So our vertex, we write in the key information. Let's go ahead and do the vertex. So vertex equals that ordered pair h and k, which is equal to -4, -1, right? So vertex at -4, -1. Now our focus, we're going to need the value of p, right, to get to the focus and the directrix. So what does p equal? So if 4p equals -8, as we divide out 4 on both sides, we get p equal to -2. All right, so p is -2. So what that means, now in a parabola with x squared, that means we're going to go down 2 units. So down 2. So what's down 2 from -4, -1? All right, we're going to be at the point -4, -3. Right, we go down 2 units. So again, this will be a good place. Let's go ahead and visualize what we have in front of us. So I'm going to go ahead and draw in the sketch of this parabola. So -4, -1, here's our vertex. Right, and again, it opens down because we had a negative coefficient. So draw in the parabola. And again, our value of p, let's go ahead and draw that point that we just mentioned, was down 2 units. So here's that point, -4, -3. So there's the value of p. So remember, p equals -2. And then to get to the directrix, we're going to go up 2 units. So as we go up 2 units, we'll be right here at what? 1 on the y-axis. So again, distance of p. So p is 2 units. Now remember, directrix is perpendicular to the line of symmetry. So we have to draw in a horizontal line. So that's the line y equal to 1. So our directrix is y equal 1. So our vertex at -4, -1, our focus at -4, -3, and our directrix at the line y equal 1. So you see your picture there of your parabola. So again, rewriting your equation, getting it in standard form was our work. We knew what we were trying to get to at the beginning. Once we had it there, we could see our characteristics. We could see h and k, we could see value of p, because we had a coefficient of first degree variable, which represents 4p. So we were able to solve for that. All right, so I hope that helps you with parabolas. So 1 through 4, good review of our first section where we studied the parabola.